6.3, problem number 9. Here's A, and we're supposed to find the f prime at 2. So that's instantaneous slope at 2. And the formula for that is the limit as h approaches 0 of the function with 2 plus h in it. So that'd be 2 plus h squared minus 3 times 2 plus h. All of that minus just 2 put into it. So that would be parenthesis 2 squared minus 3 times 2 all over h. And then we're going to do some simplification here, and we get the limit, because I haven't thought about what's going to happen as h goes to 0 yet. I can't really, because it's divided by 0. This multiplied out is 4 plus 2h, and 2h is 4h plus h squared. So I have 4 plus 4h plus h squared minus 6 minus 3h. And then I got, see, that's 4 minus 6, which is negative 2. Subtract the negative 2 is plus 2 over h, which becomes the limit as h approaches 0 of, so we've got minus 6 plus 2 is minus 4 plus 4. Those are all going to cancel. And so I got 4h minus 3h, which is 1h plus h squared over h. And h factors out, so I'm going to have the limit as h approaches 0. I haven't tried to figure out what's going to happen when h goes to 0 yet, so I've got to keep writing that limit. Factor an h out, and I get h times 1 plus h over h. And these h's will cancel, and if that's gone, as h goes to 0, this would go, as h gets closer and closer to 0, 1 plus really small number is approximately 1. There's A. Let's do B. Now we're doing f of x equals 1 over x, and we're trying to find out near 1. Instantaneous slope at 1. So we're doing f prime at 1, which is the limit as h approaches 0. And we're going to put in 1 plus h for the x, 1 over 1 plus h, a plus h, minus 1 over a over h. I've got to subtract two fractions, which means I need a common denominator, so I'm going to multiply this one by 1 plus h, and this one by 1 plus h, and I get the limit as h approaches 0 of, in the numerator I have the fraction of over 1 plus h, and the numerator is 1 minus 1 minus h. 1 minus 1 minus h. And then in the denominator I have an h. So that's all of this done to this. Let's kind of separate that a little bit. Limit as h approaches 0. 1 minus 1 is just cancels, and so I got minus h. And if I multiply the numerator and the denominator by 1 over h, That'll cancel this out. And this h will cancel the h, but not the 1, so I'll have minus 1 over 1 plus h. And now I can think about what's this going to look like if h gets really small. Well, this would turn into 1. So I have minus 1 over 1, which is negative 1. And just for some understanding, 1 over x, 1 over 1 is 1, 1 over 2 is a half, 1 over a half is 2. It's this hyperbola that you should remember from pre-calc. And this is minus 1, and 1, 1, and it's saying at 1, the slope of a tangent line is minus 1, and that looks about right. Okay, now let's do C. C says f of x is the square root of x at a equal 1. Square root functions, we're always going to have to use something called the conjugate. So beware, we're coming on to conjugate here. So we want the f prime at 1. The instantaneous slope, the slope of the tangent line at 1. It's the limit as h approaches 0 of f of a plus h. So that would be the square root of 1 plus h minus the square root of 1, which is 1, over h. Now, we usually use the conjugate to rationalize the denominator. There's a square root there. But here we're going to use it to be so we can do this. We have this problem here. We can't let h be 0 here because that makes division by 0. The conjugate of a square root plus or minus something is just the opposite sign there. So the conjugate of this would be square root of 1 plus h plus 1. And I have to multiply numerator and denominator by the same thing, or I have a problem. 1 plus h plus 1. And now, some of you are a little rusty on your square roots, so I'll try to explain this here. You get the limit as h approaches 0. We have the square root of 1 plus h times the square root of 1 plus h. That's like square root of 2 times square root of 2 is square root of 4, or comes out to be 2. Square root of 3 times square root of 3 is 3. Square root of something times square root of the same thing is just the stuff inside. So I get 1 plus h, and I multiply those. And then I get 1 times this, which is plus the square root of 1 plus h. But then I get minus 1 times that, so I get minus the square root of 1 plus h. And then I get minus 1 times 1, which is minus 1. All over h and this thing that I multiplied by. Square root of 1 plus h plus 1. Now it looks like I got worse, but I've really not, because that cancels with this, and the 1 and the minus 1 cancel, and so I have just an h left, which is going to cancel that, so I'm really looking at just trying to figure out what happens to this expression, 1 over, these cancel, the square root of 1 plus h plus 1 as h gets small. Well, as h gets small, this becomes the square root of, gets closer and closer to the square root of 1, which is 1. So the denominator is 1 plus 1, 2. So I get 1 over 2, or 1 half. Let's see if that makes sense. What's this curve look like? Well, that looks like square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. It's a sideways parabola, and we were trying to find the slope of the tangent line at 1. So that tangent line looks like it has a slope about like this, and that does look like about a half slope. Okay, let's go to here. D. D says f of x is 2 minus the absolute value of x minus 1. And we're supposed to find the slope of the tangent line at 1. So we're finding the instantaneous slope at 1. This has the definition of this with a plus h, 1 plus h in place of the x. So we've got 2 minus the absolute value of 1 plus h minus 1. This is a little confusing because the 1's look like absolute value. All of that minus f of 1, which means I put 1 in here. So I get 2 minus the absolute value of 1 minus 1 all over h. So let's clean this up a little bit. As h approaches 0, so we have 1 minus 1 in the absolute value. Those will cancel. And so I just have 2 minus the absolute value of h minus, and this is a number, 1 minus 1 is 0, 2 minus 0 is 2, so I have minus 2 over h. More cleaning up. Limit as h approaches 0 of negative absolute value of h over h. Now, we're supposed to figure out what this looks like close to 0. Well, let's come in from the plus side, like 3 or 2 or 1. And so the absolute value of 321 is 321. And we've got a negative, so it's going to be negative 3 over 3, or negative 2 over 2, or negative 1 over 1. So those all, from the plus side, we get negative 1. Because negative 3 divided by 3 is negative 1. We come in from the left side, the negative side. If I put in negative 3 and negative 3, I get absolute value of negative 3 is 3, and this would make it minus, so I get negative 3 over negative 3, which is plus 1. And if I put in negative 2, the absolute value of negative 2 is 2, and that would change it to negative, so I'd have negative 2 over negative 2, which would be plus 1. So coming from the left side, I get 1, and the right side, I get negative 1. And so the left limit and the right limit are not the same, so this has no limit. So it does not exist. Now let's take a look at the function. See, this is absolute value, which is of v. The minus 1 moves it plus 1, because it's inside, so it goes opposite. The minus here on the outside, that's times it, will flip it. And then the plus 2 moves it up 2. So we have something that looks like, at 1, it's up 2, and a slope of like this. And we're trying to find the slope at 1. Well, to the left of 1, the slope is 1, which is what we found out. On the left side, we got 1. The right side, the slope is -1. But right at 1, the tangent line, there's multiple lines that just go through that point that don't touch it. So there isn't one slope of a line, a tangent line, at 1. That's why we got does not exist. All right. And E, the last one. F of x equals sine x and A equals pi over 2. So we're trying to find the slope of the tangent line at pi over 2, which is going to have this definition. As h approaches 0, limit as h approaches 0 of the function f of a plus h, so this is going to be the sine of pi over 2 plus h, a plus h, minus the sine of a, f of a, over h. Now, some of you are going to want to just say, well, that's the sine of this plus the sine of that. But remember back in your pre-calc, hopefully you remember back, the sine of an angle plus an angle, and I had it on your readiness sheet, is the sine of the first angle, cosine of the second, plus, if the sine keeps the same, cosine, if it was cosine of this, this would be minus, and these would be a little bit different. Cosine of the first, sine of the second. So this becomes, I haven't taken the limit, so I'm going to write that. Sine of the first angle, cosine of the second, plus cosine of the first, sine of the second, and then I have minus sine of pi over 2, which over h. Okay. So the sine of pi over 2. So remembering our unit circle, sine is the y-coordinate, and pi over 2 is up here at 90 degrees. The y-coordinate is 1. So we got 1 times the cosine of h, which is 1 times the cosine of h is cosine h, plus cosine h times, cosine of the first, pi over 2 sine of the second h. Boy, did I mess that up. I was wondering that. Cosine of pi over 2, that's the x-coordinate on here, and that's 0. So 0 times sine of h is 0, so all of that is gone. Minus sine of pi over 2, that is 1, so we got minus 1 over h. Sorry about that. Okay, so now we got to figure out what this is. Well, this is not obvious. If I put in 0, cosine of 0 is 1, so I get 1 minus 1, which is 0 over 0. I don't know what that is. So we have to kind of look at the calculator and get an estimate for this. So we turn it on, we're going to have it here, we're going to clear and clear, and we're going to go up here and do cosine of x, close parentheses, because that 1 is not inside, minus 1. And this needs to be in the numerator, so I'm going to put a parenthesis here, go back and insert a parenthesis there, and then come over here and then say divided by x. And then I want to look close to 0. And it looks like I have 0.05, 0.005, and this is 0.0005 negative. So it's getting closer and closer to negative 1. That means negative 5 times 10 to the negative 4. 10 to the negative 4 really means divide by 10 4 times. So 0.5 divided by 10 times, 4 times is negative 0.0005. Same here. So we're getting closer to 0 from the negative side and from the positive side. If we look at the graph, you can see that it gets closer and closer to 0 as we come in. The height gets closer and closer to 0 as the x value gets closer to 0. And so this has 0. And let's make even more sense out of this. Let's go and graph the sine curve. And what we were looking for was the slope at pi over 2. Now, if you remember, the sine makes a complete cycle by pi over 2 pi. So it's here at pi, and at pi over 2, what is the slope? The slope is 0. Slope of the tangent line.